Hi everyone, in this video we will talk about basic calculations. Let's jump into it. So let me zoom this a little bit so it will be very clear. So basic calculations in SQL can help you make sense of a larger amount of data by allowing you to perform mathematical operations on the data, right? And also extract meaningful insights. So let me go again. It says basic calculations in SQL can help you make sense of a larger amount of data by allowing you to perform mathematical operations, keyword mathematical operations, right? Keyword mathematical operations on the data and extract meaningful insights. Now, there are a few ways in which basic calculations in SQL can be helpful, right? We've worked with aggregation, right? We've done a lot of aggregation in the previous videos, right? Using aggregated functions like count, sum, maximum, average. We've done a lot, right? From sorting, group by, aggregation videos, we've done a lot, right? So with that, we've done a lot of basic calculations, right? Where we do count, sum, those are basic calculations in our select statement, right? We've also done grouping, right? Where we've grouped by different columns, by one or more columns, and we have select statement that has basic calculations in it, right? And then there's another way in which basic calculations can be helpful in terms of filtering, right? We'll see some examples, right, about SQL's where clause, which allows you to filter data. It's very important. It helps you filter data, right? Filter in the sense that you have a lot of entries and you want to just get where so column is equal to this, right? So we'll see one or two examples on that, right? It says SQL's where clause allows you to filter data based on specific conditions, right? Yes. By incorporating calculations within the where clause, you can perform comparisons or calculations on data values to filter out the records that meet certain criteria. Right, so for example, you can filter out products with sales below a certain threshold. Exactly. So you can say select sales. For example, select sales or sales amount or sales ID from sales table where sales amount is equal to $50, right? So that's you filtering the sales amount to just be $50. Or we can say for where sales amount is less than or equal to $50. So all the records that are going to show would be results that are less than $50, that are less than or equal to $50. So that's basically what SQL where clause does. Then another way of using our calculated column, or rather our basic calculations, would be in using it with calculated columns, right? So let's say you want to create a new column, just like one of the examples we did in our previous videos, where we wanted to create our new total column, right? Where we had our original total column too, and then we multiplied it by $20 or 20 euros, the case may be, and we named it a new column, right? That's basically we having a basic calculation, right? What we did was we multiplied the original column called total and we multiplied it by 20, right? That's a basic calculation. That's a basic calculation, right? It says SQL also enables you to create new columns based on calculations performed on existing data. These calculated columns can provide additional insights into the data. So some of the commonly used mathematical operators in SQL include definitely subtraction, multiplication, division, modulus, and the rest. So by using basic calculations in SQL, you can manipulate and analyze a larger amount of data, allowing you to identify patterns, trends, and anomalies. So let's just try to create these mathematical or basic calculations on our DBMS, right? So our normal routine, let's see, just copy this, then we paste. Yep. So we can call this basic mathematical calculations, right? So let's do Control V. Then we'll do our multiple line commenting. Yeah. So I don't know if I should. Yeah, let's still comment that. So just say, let us rewrite this and explain it, right? So we said, let us explore some examples using the Chinook database to demonstrate basic calculations. Now, the first example we want to explore is calculating the total price of each invoice, right? And let's say we have a total price, right? We want to get a new total price that has a tax amount on it, and that tax amount is basically 1.2, right? Or whatever, you can call it 12% or 1.2, right? We want to get a new column, which was what we described here. We can actually get a calculated column now, right? A new calculated column of our existing calculated or our existing column, right? So that is what we want to do. We want to get a new column, a new calculated column, right, called total with tax of our existing column, which is total, right? So for me to do this, let's first of all do select all from invoice. See invoice, right? So we just have a sneak peek of what we want to do. So we run this. So this is our table. So basically what we want to do, we want to create a new calculated column called total with tax based on our already existing column called total. That's basically what we want to do. So, and for we to get that newly created column, we need to do a basic calculation, right? A basic calculation involving multiplication. So now for we to do that, we'll come on our select statement and we'll say, okay, I want to be able to view in my final result, I want to see my invoice ID column, right, comma, I want to also see my existing column called total, right, I want to see it in my final result, and then I also want to see a new calculated column where we multiply our total column, our existing column that we have, multiply by 1.2, right? And then after doing that, give it an alias total with tax, right? So it's as simple as that. So when we run this, watch the magic. So we have a new calculated column that we calculated by multiplying 1.2 to our existing column. Right, so we've been able to create a new calculated column. So let's try second example. Sorry about that, guys. Second example. So we want to be able to. So it says, okay, they paid basic calculation to add a 20% tax. 20% tax should be 20% tax, yeah. 2/10 should be, So, 20% tax should be. So I'm looking at 20%. So pardon me, guys. I have a lot of things in my head. So 20 divided by 100. Just want to be sure. 0.2. So it's not supposed to be 1.2. It's supposed to be 0.2. So what we did here, right, is supposed to be multiplied by 0.2, making it 20%, right? So yeah. So the idea is we understand what we are trying to do. We are trying to create a calculated column with tax added to it, right? So that's not a problem. So let's try to get second, featuring the tracks for the album with album ID 71, and also the track that has the highest track duration in seconds. So what we did here is we also incorporated our where clause. Remember, guys, our where clause also helps us to filter. So we want to also showcase this filtering, right? We've been able to showcase our calculated columns. We want want to showcase filtering. So remember, we need to use our where clause. So for me to do that, let's do our normal routine. Ctrl C, go to our Chinook database and we paste. Then we have our single line commenting and then our multiple line commenting. Yep. Yeah. So let's close this as well. So now let me explain. It says filtering the tracks for the album with album 71. Right, and also the track that has the highest track. So now we've understood that we want to get the tracks that are only in album ID 71. So in that sense, we need to filter, right? We have a lot of album IDs, right? And we have a lot of tracks in different albums. But in this case, we want to filter the tracks for only one album, which is album ID 71. And also we want to checkmate the track that has the highest track duration in seconds, right? So for me to do that, we can start off with select all, right? From track, definitely. Our table should be track. We want to see everything on track. So before we do that, let's see everything. So we have our track ID, which signifies each track in whatever album, right? Then we have milliseconds, bytes, unit price. Okay, nice. So after that, we can say, because it's saying that we want every track in our track table, right? We want to see all columns, we want to see all columns in our track table, right? So in this sense, in our track table, I'm just interested in the album that is 71, that has the ID 71. That's where clause or your where clause comes into play, right? So we want to filter all this to just give us album ID that has an ID number 71. So we need a where clause. Remember, you cannot use order by for that because you're not sorting. You cannot use group by for that because you're not trying to shred anything into groups. We want to just filter to see only the result that has album ID 71, right? So we do where our album ID is equal to 71, right? So this is us filtering. Then if I run this, so I'm doing this one after the other so that you would be able to understand what this query is talking about, right? Once I run this, let's see. So if you notice, all our album ID is 71, right? And then we have different tracks in this album ID, right? That's basically what we want to do. So within all the tracks in this album ID, the second ask is we want to now track the track. Sorry about that. So we want to record the track, not track the track. We want to record the track that has the highest milliseconds, but now not in milliseconds again, in seconds, right? So there's a way we can do basic calculations to have that, right? We can convert our milliseconds to seconds, right? And we know that converting milliseconds to seconds, we need to do away with this milli, which is basically 1000, right? That's why we divided by 1000 to make it just seconds, right? So these calculations here is what we call basic calculations, and they are being found fine. You can locate them or you can get them in your select statements, right? And so with this, it gives you a new column. That's basically it. So now after doing this, we have this. Then the next thing for us now is to make sure we have milliseconds in seconds, right? So we can basically clear this. We don't want all columns, but I would prefer for us to have all columns. Then I'll go to do a calculation, milliseconds, which is this column, divided by 1000, right? So let's see once I run this, let's see what will happen. If I run this, see, so it has given me a new calculated column called milliseconds divided by 1000, right? So meaning all this entries are in seconds, no longer in milliseconds, right? So for we to have that, for it to have a column that will be descriptive, we need to use our alias. So we can say as, so we don't want to name it as milliseconds divided by 1000, right? You can name it as seconds. So, or you can name it as duration in seconds. Duration in seconds. Yep. You see? So I can run this, and then we have what we have. We now have a new calculated column based off our basic calculations, right? In our select statement. Sorry. Based off our calculation here in our select statement, we now have a new column called duration in seconds. But hey, we are not done. It says track the highest track. Oh, I've said it again. Record the highest track duration in seconds. So for we to be able to see the highest recorded track that has high number of seconds or has high duration, we should sort our duration in seconds column in a descending order, right? So that's what we will do. Come and do order by, remember we've given it a name, duration in seconds, right? Unlike this, our example, we named it seconds. That's why we have seconds here. So I'll do duration in seconds. Then I don't want it to sort automatically. I want it to be descending order. So once I run this, voila. See, so it is being sorted. Yep. Oh, it has not sorted, guys. That's why we have 223, 263. It has not sorted because it does not understand. Right? Remember, we named it duration in secs, not duration in seconds, right? So let's be exact. Once we run this, yes. So automatically we now know that the track name Aprendendo Jogger with the track ID 890 has the highest duration in seconds. It has 290 seconds. So it's a track that has 290 seconds, which is the highest track that has the highest duration. See? So you see how we can get a lot of insight, right? A lot of granularity in our data set with basic calculations, right? Filtering, grouping, aggregates, using calculated columns and the rest, right? So you see how beautiful this concept is. So let's head over to other examples. So I believe this is going to be easy, right? Converting milliseconds to seconds and rounding the result. So this is basically going to be easy because the calculation done here is what we did initially. But now, instead of having this, we can also have our decimal points will be rounded up to 2. That's basically what this function is talking about. Round milliseconds divided by 1000.0 and then round it off by 2. So we just want to have our results will be in decimal points or decimal places 2. Right, so let me do that, and then I would expect everybody to solve this because this is quite easy, right? Getting the select average total as average invoice total from invoice. This is basically a very easy basic calculation to do. But let's try this. So once you go, copy, paste, then I'll do my single line commenting, and then I do my multiple line commenting. Close it. Yeah, so let's go. So it says converting milliseconds to seconds and rounding the result. So this is basically what we did initially, right? But without our filtering, right? So our results will still have a lot of album IDs, right? So let's still do the same thing. Select everything. So instead of selecting some columns, select everything, right, from tracks. There's no table called tracks, so it's track. So once we close this and run, so it gives us everything, right? It gives us all the columns and everything, all the entries in our track table. But hey, we want to have our milliseconds to be converted to seconds, and then we want to round the result in 2 decimal places. So we can do milliseconds, we can do another basic calculation. Milliseconds, which is this column, divided by 1000.0. So I'm putting 0.0, so we'll have our result to be in decimal places, right? Then let's see. Once we do this, let's see. Let's run this. See? So it's giving me decimal places because I did 1000.0, right? It's giving me different decimal places. But now, instead of having 3 decimal places, right? And also we need to change this column name, right? Instead of having 3 decimal places, we want to round this off to just 2 decimal places. So the idea is we want to have 343.71 or 72, basically. We don't want 719. So that's where round function comes into play. So we can do round, right? And then this, then come here and we'll put a comma. Say after this, please, the result of this, round it off to 2 decimal places. And then the result of this round, we want to term it as seconds, basically. Right? We want to term it as seconds in 2 decimal places. In 2 dp. Yeah. So let's do it like that. So let's run it again. And also do, so we now have converted milliseconds to seconds in 2 decimal places. So that is that about that. So that's what we are trying to do here, and then I think that works well. So if you notice, we've been able to create a lot of basic calculations in our select statement, just like this, milliseconds, just like this, total, and also we've been able to use our where clause to filter, right? Able to use our where clause to filter, right? And also we've been able to create calculated columns just like seconds in 2 decimal place column, right? So with that, I'm expecting everybody to also work on this to get the average invoice total, right? And then I think with that, we've come to the end of this video.